Great, let's get started today. Thank you everyone for joining us. I am very much looking forward to introducing Sven Ruppert from JFrog. He is joining us today to talk about polyglot apps lead to polyglot security holes, and it's time to fight back. All right, Sven, I will let you have the floor.
Okay, hello from my side as well, here from cold Germany. So I was reading already a few from Greece and Mexico, and it's definitely warmer and better weather than here. So what we are talking today is a little bit about polyglot security holes. And during this talk, if you have any questions, feel free to use the chat. Feel free to use this Q&A window from Zoom. I will try to have an eye on this one. So if there's anything I see and it's the right time, I will give an answer. Otherwise, I will do this Q&A in the end of the session. But if there's anything, just, feel free to ask via the chat. And then I try to give an answer during the talk or immediately in time if I see it. So now one of the most critical things, I will start sharing my screen. Let's see if this is working. So hopefully, can everybody hear me? Just a sign. Hello. I hope so. So, okay, where is my PowerPoint? Okay, so now I have to grab my chat window. This is something weird in Zoom that always they are catching this chat window. So let me see. I have my chat back and now I'm ready to go. So if there's any question, let me know. If you have any comments, feel free. And now we will start. So polyglot. Polyglot is a complicated word, but what we want to talk about. So first of all, my name is Sven. If you want to reach me, well, over the internet, take Twitter, take LinkedIn. You can see me on YouTube. By the way, this background you see here from me without the screen sharing is just taken from one of my outdoor trips. I'm recording IT-related stuff in the woods. So if you're interested in this one, have a look on my YouTube channel. I have them in German and in English. Feel free. So, and JFrog, what we are doing with JFrog, we are talking about DevOps and explicitly about DevSecOps. And this is what I'm doing as developer advocate at JFrog. So I'm focusing on the security part, and this is where we want to go today. So, by the way, slides and all this stuff. And Ruppert, if you want to win something, here it's an Amazon Echo Show 5. Go to this bit.ly link, and then you have the chance to win one. I don't know, I think 2 business days, 3 business days, something like this, and we will announce a winner. So feel free. If you want to have this URL later on, just let me know. I will copy paste it in the Slack later in the chat here. So, okay. Cloud native, the big word, huh? And I don't want to go in all these details, but cloud native is perfect to show a few things. But even if you're working with monoliths or serverless or whatever, more or less the principles I'm talking about is the same. So this is this is one thing that you should have in mind. Don't fix too much on this cloud native stack here. It's just one thing. But we have this service-oriented and API communication. These are quite generic things. If you're thinking about splitting up, for example, some services to microservices, then a machine is not really good in helping you in if you want to decide this is a use case for this microservice and this is a use case for another microservice. So here the human has to decide and had to split up and all this stuff. The same with the API communication. So you have to decide what's going over the wire, but the tools are start helping a little bit more with how to encode this stuff, how to serialize, unserialize, and so on and so on. But on the other side, you have these generic things that are in these layers. And if you're going to this container-based infrastructure to this DevSecOps part, then you see that more and more the tools can help you with certain things. And here what we wanted to reach was splitting up a microservice. Sure, we want to have these short release cycles. We want to rewrite instead of maintaining old stuff. And this is, it's fine, it's nice. We as a developer, we like it. We love it to play around with new stuff. But on the other side, I'm coding Java now since, I don't know, 1996. And if I would start coding in Go tomorrow, I wouldn't be a senior anymore. So it would be nice. I would learn it maybe fast or not, but I would do all the mistakes the junior would do more or less in the same way, maybe in a shorter time, but I'm not senior anymore. And this is something that is tricky. So new technologies are fancy, you like it, but on the other side, you have to make sure that these new technologies are not bringing a huge stuff in. So you have new tools, you have new best practices with the language, and so on and so on. And by default, if you're talking about the cloud native stack, or in general about that microservice zoo or serverless or whatever, if you're splitting up, then we are more or less just increasing the amount of technologies. And per definition, we're talking about polyglot systems. So different technologies in one thing, and the amount of different technology is increasing. And well, this is something you should have in mind. But splitting all this stuff away, so just focusing on one single application, call it monolith, call it microservice, call it serverless, I just don't care. We have more or less always the same stack here. And here again, we have two dimensions I want to look at. So first of all, we are writing an application, and this application is what we're coding, and we have some use cases, and we are doing all this stuff. After this, we're introducing the next layer. It's operating system layer, for example, Linux. And then we are wrapping it in Docker. We are composing it in Kubernetes universe. So all this stuff is more or less layer by layer by layer. We are increasing the complexity somehow because we're adding new technologies, and they all have to fit together. But one thing is for sure, if you're adding some vulnerabilities in the first layer, for example, inside the application layer, then it will be existing over all other layers. And the same with compliance issues. So if I have the wrong license at the right place inside the project, I will have a challenge because it can just kill my business. So what we are thinking about this one, what we have to do here. But there's one thing, even here, we have some parts. We have in all layers this more technical part, and we have this more domain-specific part. So inside the domain-specific part, talking about security is more or less talking about the semantics, talking about the processes, or security per concept and all this stuff. But if you're talking about the technical things, and here is where the tools are way better than in the domain-specific area, is that they can help you scanning for vulnerabilities and all this stuff. So here again, on all layers, we are adding technologies, but we have a pure technical side, we have a domain-specific side. And the most people, what they forget in all of this is we are talking about the whole tool chain as well. So inside this DevSecOps, but this is the interesting thing. In the cloud native, we are talking explicitly about DevSecOps, not DevOps anymore. Means that we have the whole tool chain. This is part of the whole production line as well. And here we have to think about the term security. But I want to talk about some polyglot stuff. So what I'm explicitly excluding here, this part is a concept phase. So I'm not talking about how to make a strong concept in terms of use cases and all this stuff. So I'm just focusing right now on the technical part. And yeah, that is one thing that you should have in mind. Security starts early in the concept phase, not just during the coding phase. So even in the concept phase, you have to think about the term security, but I'm excluding it here because this is a too broad scope for now. So let's see. One thing I often hearing, and it took some time to remember something, is, for example, shift left. If you want to learn more about this topic, search for the term shift left. And what shift left means is if you're just rotating this picture by 90 degrees and you're starting from left and reading to right, then that's the earliest point is writing an application before you're wrapping it in the operating system, before you're using Docker and so on. So shift left means dealing with the security term as early as possible. And for this talk, we are stopping with a left concept at the application. We are not going to the concept phase, but even this would be more left. So what does it mean? Shift left means that we have to think about all these vulnerability and compliance issues as early as possible. And there's no dedicated phase where we have now security scans and then everything is done. But, well, I want to show an example about this polyglot world. And one example is if you are a server-side developer and you have, for example, in Java, and you have to write at least a graphical user interface, or you have to create a web app. It could be an internal one for administrative stuff. It could be a customer application, whatever. Let's think about how to write this web UI. And if you're a core Java developer, then all this web UI stuff is far away. So you want to have Java, and this is where you are. And then you have these different technologies. For example, here, this HTML5, CSS, and JavaScript, because we are talking about, for example, web components on the graphical user inside, so on the website. And these are two different things. But what will happen here? As a Java developer, if you're familiar with this technology, you have two choices. You can learn HTML5, CSS, JavaScript so much if you want, if you can, if you have the time, if you like, whatever. Or the other thing is you're searching for something that is wrapping this technology for you in a way that you don't have to deal with this. Let's have this one. So we have this web components on the one side. We have the Java side where we want to be, so where we are normally in. And then we have this kind of communication in between. For communication, you will find, for example, Java as well. So you're happy with this one, but how to deal with this now. So here's an example just to show how technology is hidden. I'm using Vaadin. Vaadin is an open source framework. You can use it to build on the server side with a button on the screen, and it's based on web components. So have a look at this one, but it will show you quite easily how we are mixing up different technologies. And I want to show you what happened if you want to play around and what this convenience is bringing you. At this part, if you're digging a little bit in this API, you would see something. I don't want to go in all details here about this one because we want to focus on the security part. But if you're checking, what they have done is, for example, they started mapping these different technologies together because they want to have this convenience as a Java developer and will give you some other technology, some other layers somewhere. And here, for example, if you're dealing with a pure NPM stack, you would have three things. You have this NPM install to grab web components so that you have it in your local repository. Okay, it's a package manager, and you're declaring something like take these components with this version, and then it's grabbing from an external repository, storing on your local hard disk and temporary folder, something like an m.2 folder, like it's done with Maven. And if you want to map this one on the Java side, for example, with this Vaadin framework, you would have something like an annotation. And for you as a Java developer, this is convenient. You have just an annotation, npm package on a class, and you have this value. It's exactly what you would use with the npm stack. So this coordinates or this component, and you have the version. So this is fine. On the other side, you would need now something like an import statement. It's the same way like on Java. So you have an import statement of a class so that you can use it. And on HTML5 page, you have nearly the same. You have an import, and then you're explicitly addressing one class or one component. And you would find, hey, I have a Java component, a Java annotation here, and it's exactly the same. So if I want to have a badge, then I'm just taking this annotation and writing the coordinates from this web component in. And then it's somewhere here. How to use this one now, how to map it to the Java side. If you're inside the web application, you would take this tag, for example, UI5 minus badge. And to map it to the Java side, you would have a tag like UI5 minus badge. Everything together is more or less a mapping between different technologies. At this annotation level, you're purely on the Java side. And if one of your colleagues would do this one, would say, okay, we have to code now all these web UIs, but we want to have it as a Java developer. One of your colleagues would exactly do this one with web components you need. And this is another thing. You can do it with every web component if you're using this Vaadin stack. So this is an example how I map the UI5 components, for example. Then it would have a class, extends component, Okay, and then you have these three annotations. What have we done now? We mapped not only technologies in different binaries, we mapped already life cycles. So with these three annotations at this Java class, if I'm somehow creating this instance, I would have an npm install, I would have an import, and I'm declaring a tag. So I have a quite complex thing here already done. And if one of your colleagues will use exactly this component, I'm not sure if he's really aware of all these different stacks and what is behind this. And there are some other things that are not so nice and they are somehow critical. Let's see, you want to start building some attributes. Here it's quite easy. You can map it on the Java side as well. So with get elements and property and you're setting some stuff. So even this, if you're a Java developer, you can do this one quite easy. Have you understood the whole NPM stack so far? No, I'm not sure. You're just reading some documentation and see, okay, there's an attribute called color scheme. And then you're reading in the API documentation, okay, you have something like get element set property, okay, this matches. And then you start mapping all this stuff. I mean, this is great. It's very, very convenient. And if you think about how to get something out, the next thing is, okay, I'm not only possible to set an attribute, I can grab stuff out. What happened now? From the browser will be something encoded, will be sent over the wire into your system, will be converted somehow to some Java representative thing, instance, whatever it is, and you're accessing it. Wow, this is this is really good. So the convenience factor is enormous because you can just start coding Java. Even if you start thinking about, okay, I don't want to have attributes, I want to have a tree because I'm in the Java world. Now you start thinking about how to map all this stuff. And then you're saying, okay, if I have a component and there's a complex child in, then I'm doing it exactly with the child as well. So here you see, okay, there's an URL5 icon, and then you start again. You have this URL5 icon class, extends component, you're adding just these three annotations, and you will see, okay, reading a bit documentation, you can connect both. This setter is now something like get element, append child, and this one. So we are now able to code on the Java side a quite complex thing. And you have different components. You have a huge amount of communication. You have a huge amount of technology stacks in. And in the end, if you're mapping this one person in your team, and will make a jar out of it and will give it to you, you as a developer would just see new UI5 batch, set icon, set text, and add action listener, whatever. And you would get something like this on the screen. Say, what happened here is it's easy to map this technology. You have a huge lifecycle in the background. And if you're checking here's a dependency tree, it's a nightmare. You have not only one technology, you have now two technologies. You have two package managers in the background. You're dealing here, even if you're not seeing it, with different technologies in a level at a level that is well hidden. So you have to search for all these traps where you're just combining technologies like this. On the other side, I'm assuming that this trend will be coming more and more, because if you want to have more complex things, if you want to have more generic things on the end side, but more easier ways to formulate your use cases and all this stuff, you need this convenience to have the right speed to have this use case fast enough on the market. So we are talking about time to market. So there's a requirement. It must be pushed to production as soon as possible. So we will have this one. And this is just a layer inside the application. You will have the same on the operating system or inside Docker, inside Kubernetes. And this is something that is more and more coming. And this means we need more and more aware of it. And we need tools that help me to identify what's going on here. By the way, if you want to have a look at this, you're a Java developer, you have to deal with web components, you want to try it out. I have this one on GitHub, and then you can just try it out. It's a good running proof of concept. I used it for some small projects. It's open source, Apache license. Grab it, try it, and if you have some feedback, let me know. I'm more than happy to see it. What we have now, we have now the following. We have now an application, and instead of playing with one package manager, we are playing indirectly with two package managers. With all the life cycles, with all the dependencies, we are all grabbing these binaries. And now we need something that will help us to identify the whole stack, not only the Java side. It would be a disaster if you're just checking vulnerabilities on the Java side. We have to check it on the NPM side now as well. And this as early as possible. I have on YouTube a few examples how to do this one. I'm explaining it here in a few words, but if you want to have the long version, go to YouTube and check it out. For example, how to harden this Vardin framework with the stuff I'm showing here right now. So next is thinking about this convenience part and thinking about that we are just use, or what means just, we are using open source. I really love open source because we have the possibility to check, we have the possibility to analyze, to fix bugs and all this stuff. But if you're looking how much of this open source stuff we have in, it's quite a huge thing. So half, maybe 60%, maybe 40%. I don't want to be so strict with the percentage, but it will be a bigger part here. And that means we are grabbing something because we don't want to reinvent the wheel. On the other side, we have to trust something that's coming from outside. So we have to check against vulnerabilities and we have to check against compliance issues. And this of all transitive dependencies. If you're just adding a few dependencies just for fun, generate the whole dependency tree of your application and check how many dependencies you have and just assume how much time it would need to scan all of this. But we have two different things. I mentioned compliance issues and I mentioned vulnerabilities. And one thing is, even in a polyglot system, you have this indirection to other technologies, means you have to have an eye on compliance as well of the whole stack. But the good thing with compliance issues is in the beginning, you need a lawyer that's defining this is a good license for your project and there is a bad license for your project, whatever. If this is done once, then the machine can do it constantly. And if you have a compliance issue somewhere, then it's just this tiny thing. So you have this library, you have to grab it out, and you have to find a semantic equal solution running under a different license. So the process is quite clear. The machine must be must be initialized with the information, what's a good license, what's a bad license. But if there's something found, the process is clear. You have to remove it. That's it. Its vulnerability is a different beast. If you have vulnerabilities in different parts of your application over the whole stack, then maybe the single vulnerability is not really bad or high risk or whatever. But all these vulnerabilities can be combined to different attack vectors. And this means you're not only talking about the single vulnerability here, you're talking about the whole composition of vulnerabilities and this over all dependencies and this over all technology layers. And this is a base. So you need something that will give you the full impact graph. So it makes no sense just to focus on one layer, on one technology. You need the whole tech stack, everything, from the application up to Helm chart, everything, even the tooling itself. But what is the lifetime of a vulnerability and what's a critical part and where we can jump in with this? If there is a vulnerability and it's created per accident or someone want to have this vulnerability in somewhere, we have no way to influence this one. So someone will create some vulnerability. Some vulnerability will be somewhere. And then we have this time until this is found. Do we have any chance to influence this one or to make this faster, shorter, whatever? Yeah, if you're a security researcher, we can work on this topic, but I assume that most of us are not security researchers, so we have just to wait. Then there is this information found. So the vulnerability is found. Someone found it. Now we have to weigh the good one and the bad one. The bad one is just selling it in the darknet, and the good one is going to the company that is a provider of this binary or this group or whatever project. And we'll give this information to them. And sometimes they decide, okay, we'll wait until 2 weeks before we are making it public so that you can create a patch and all this stuff. And can we influence this time frame? No, if you're not directly affected because we are the persons that is contacted, we have no choice or no possibility to make this shorter. Then there is this information available. Do we have access to it? Well, mostly not directly. So we have this free vulnerability databases, we have commercial vulnerability databases, and there's a big gap between the commercial and the free one. If you like it or not, whatever, I don't want to say it's good, it's bad, it's whatever. I'm just mentioning that mostly the commercial vulnerability databases are faster and have more information as a free one. Maybe the free one will have the same, but maybe later. So what can we do here? We can wait until this information is consumable for us. If you're spending money for a service, or if you're just waiting, whatever you're choosing, at some point, this information will be available for you. So it's now consumable. You're not even just know it, it's now consumable. Until this time is, that this information is consumable for you, the timer is starting. So now that the clock is running, you would say in German. So now you must be fast. So if you have a good CI environment, everything is automated, perfect. Now you can start thinking about, okay, I know there's a vulnerability. I have to change somewhere in my stack and it must run in production. So time to market. We are talking about exactly the same, no? Time to market. So there is a need and we have to push it as fast as possible to production. So, and this is the only time we completely have under control. And mostly this is a quite long time. So for a lot of projects, even this, there is a vulnerability until it's running in production. We're talking sometimes about weeks or months or even longer. So it's a disaster. We're now checking the whole system application layer, for example, and the difference between make and buy. Make is you're writing it by yourself. Buy is you're adding a dependency. You will see that inside the application, you will have at least some part of make, because this is the biggest part mostly, because you're writing all this stuff. But even the buy part, so this, I have a lot of dependencies, is a quite big one. If you are going to the operating system layer, mostly I'm just adding some configuration, and the rest of this operation system is a dependency. And the same with Docker. The first statement is from, so it's just a dependency, and then we're adding some stuff, and the same with Kubernetes, and so on and so on. And the whole tool stack, for example, your compiler, your JVM, and all this stuff is a dependency models. So we are grabbing a huge portion to our tech stack, and this is a binary that's coming from outside. And this is why I'm saying mostly, if you want to start with the security part, focus on the binaries, the external dependencies, because this is the biggest part in your whole tech stack. Whatever tech stack you're looking at, mostly this is the biggest part. So if you're focusing on scanning this one and making this one clean against known vulnerabilities and compliance issues, you have the low-hanging fruits, the quick wins done. And then you can start analyzing your code with AI or whatever. But having the dependencies under control is a key point if you want to start with security. So what is helping you? You have this vulnerability and compliance issues, and both will push you to some change in your code. And if you're changing something, well, the best you could have is a perfect test coverage. So if you have a really strong test coverage, then you can start shifting versions around. Let the test suite run and be sure that you can push it to production, because you have the same behavior of your application. And I personally, I'm a fan of mutation testing, because it's way stronger than pure line coverage. Whatever fits to your needs, decide what is the strongest line coverage you have, or how to make this test coverage as strong as possible, because this is your safety belt. Because the first line, or the first thing working against vulnerabilities, means you need a very efficient dependency management, because a very efficient dependency management will have the biggest impact, or the fastest impact of the biggest part of your project. So TDD is just working hand in hand with security. That means quality and security, they're just going in the same direction, and this is perfect. So they are not running in different directions. If you're now thinking about, okay, we have different dependencies, we have different technologies, and even inside the application, I have different technologies, because we are talking inside an application about polyglot systems. But even if I have different microservices, this polyglot system is even bigger, even more components and technologies are running around. It would be perfect if you would have something that is able to handle all these dependencies, all these different dependency managers, to aggregate all binaries in one logical point. Why this is important? Because if you have all binaries, this logical point where everything is running together, you have the perfect place for scanning the dependencies, so scanning against compliance and vulnerability issues. And that is what we are delivering here with Artifactory and with X-Ray. So with Artifactory, you have this dependency management inside, so a binary repository, and you can have your Maven repository, your Debian repository, and everything together. And if you have this, your Artifactory instance as a gateway, then you can go with X-Ray, this binary scanner, can connect and analyze against compliance and vulnerability issues. If you want to try it out, we have a free tier. I will share the URL soon so that you can just try it in the cloud, but it's on hybrid environments, means half cloud, half on-prem or completely on-prem. So it doesn't depend, but you need this single point where you can just analyze all binaries of all technologies. And the most people, and this is one thing, the most people forgetting just the toolstick itself. So they have all the dependencies of the application, but they are not scanning their binaries they're using inside the production line. And even this, it's just a dependency. You're declaring it, you need a place to store it, take a generic repository, put your compiler in, put your whatever, just push all this stuff in to make sure that it's immutable so that you can reproduce the state every time to analyze it. And on the other side, that you can just scan your binaries. That's it. And even a compiler can have a wrong license. Okay. We have different ways to formulate it. So if you have an auditing system or you have some compliance rules or some documentation that's describing all the stuff, you need some ways to describe what's written down somewhere. Excuse me. And on the other side, you need something that is mapping to the technology. And here we have this concept of rules, policies, and watches. I'm not explaining everything in detail, but the main thing is you have this rule that is an independent stateless definition. If I find something was a CVSS 7.3 or higher, then break a build, send a webhook, send a mail, whatever. So different things you can do. And this is independent from the technology. You're just describing what should happen if I found something. Then you have this policies. The policies are the composition of these rules under a logical name. And it would be, if you have a document, an auditing document, a security description somewhere, you would have the single actions, what should happen inside these rules. And then every chapter would be a policy. And then you can have even a one-to-one mapping between your documentation and requirements to what's running inside X-Ray. And then you want to have this technology independent description, what should happen, and you map it against repositories, and it's called watches. So then you're combining these policies with watches, with Maven repositories, Docker, whatever. So it's free to combine. And this is what we have: watches, policies, and rules. If you want to know this in detail, I made this how-tos, and then you can really see how to create it, what are you doing, all this stuff, or just check out for the webinar on our site. Then you can get this one. But in the beginning, during the beginning, we spoke about shift left. What does it mean? What does shift left mean? Shift left means that you want to start as early as possible. Assume the following. You're starting a proof of concept. You're happy. Damn, yeah, finally, I can start coding something from scratch. I can choose some technologies, whatever, or I just playing around with some stuff. And then you start aggregating technologies. You're writing your proof of concept, and after the first day, you're committing the first things and you're pushing it, and you have to create this pipeline, and then you're creating the pipeline inside your CI environment. The CI environment will start working, and then at some point it will say, oh, this dependency you're using, sorry, but too many vulnerabilities in, or wrong license. There's a transitive dependency, and this is just not possible here in this project. The maintainer of this project was not good enough in checking this one or maintaining this one. What have you done? You just wasted a huge amount of time, and this is a huge amount of money. And we don't like to waste money because we have to expend it somehow. So we have to remove this time, or we have to shorten this time as much as possible. So having all this stuff inside the CI environment, it's perfect, but it's not the earliest point. You need this information earlier. And one early stage is having this information inside your IDE. And it means if you're working with Java, for example, and you're dealing with this dependency management system, the first thing before you're doing something is firstly you are declaring some kind of dependency. Oh, I want to have JUnit 5. Or I want to have this library, this PDF library, or this algorithm, whatever. So you're declaring this one inside the POM XML or Gradle or whatever you're using. And immediately at this point, you're declaring the coordinates, so the binary and the version. And at this point, the IDE plugin that we are offering for X-Ray will grab this version information, these coordinates, and also vulnerability database if there's anything that we should know, any vulnerability or any compliance issue. And this for all transitive dependencies as well. So if you're adding a dependency, not only this one is important one, but you need all transitive dependencies. And this is the IDE plugin doing. So you can just install this IDE plugin. It's open source, it's free. So even with a free tier, you can connect with the IDE plugin to your free tier. And in the free tier, you have slightly limited version of X-Ray that you can scan or use to scan against non-vulnerabilities. So inside here, we have it for IntelliJ, VS Code, Eclipse, whatever, but feel free. So try it. And then you will get immediately this information. And here's a screenshot. It's just showing a little bit the tree. You will get this tree of all dependencies. So you see the whole hierarchy. And then you can start searching for stuff you don't want to have. And then you start replacing these dependencies. And again, if you have good test coverage, it's exactly what you need. So, and how to do this one, I have there this whole process, how to exclude, how to add a new dependency and do this until everything is fine. I have a YouTube video in this JFrog how-tos where I'm explicitly showing this process and how to install the plugin, but mostly searching for the plugin and install. So this is one thing. So inside the IDE, you will have now the whole information about the tech stack. Back to the Polyglot topic. If we have now this dependency, my colleague mapped all this stuff against NPM. I'm just adding a Maven dependency. I'm not aware of this one. I'm grabbing this dependency, but the lifecycle mapping will include all those technologies. You will see there in this tree, you have a tree for Java, Maven, and you will have a tree for the web components for the NPM stack. So first of all, you see that there is some other technology in the background. Second, you see even for this hidden technology that there is a vulnerability and you can start working against it, even if you're just declaring a component. And that's what is really saving time and money and is reducing risk. So focus on something that will give you as early as possible this information. Later on, if you're inside the web UI, you can have the full impact graph here. Line interface that you can completely provision all this stuff via command line interface if you want, or via REST. What can you do with this? If you're talking about this scanning against vulnerabilities, you need some process how to handle this one. Sure, you can break a build. This is one thing. You can notify via email. Okay, but the really cool thing is that you have two things, the REST API to interact with the machine, and the second one is a webhook, because with this one, you can start integrate third-party components and you can build semi-dynamic workflows. There is a vulnerability in this Docker image. I start now a process that will make a dedicated quarantine repository. I'm pushing my stuff in. I'm automatically doing all these updates in this Docker layer, for example, and then I'm scanning it again or whatever. So you can start working with semi-dynamic workflows. And this will give you the possibility to feed reportings like compliance tools. You can pre-harden images if it's just an update of the versions and so on and so on. So that's one thing. And yeah, if you want to try it, feel free, grab this one, jeffrog.co, free tier DevOps_CDF, and then it will come to the point where you can start a free tier. And if you want to see how to do it, I have some how-tos, so how to start the free tier, and platform overview if you want to have a short guideline. Otherwise, check out the documentation or just ask me. And then you can start this one. And what should you do? To start a free tier, it will take 5 minutes or so. You're just creating the repositories you need, for example, your Maven repository. You're changing inside your POM it in a way that you're using exactly this Maven repository, and then make a clean verify. That's it. And then you have all informations. Or earlier with the EDA plugin, just connect to your X-ray instance and let your dependencies scan. That's it. So how much time you need to start with DevSecOps? Below 2 hours if you're doing everything and slow and reading and all this stuff. But then you can start even in your project just with, I'm scanning all this stuff. I want to have the full impact graph at least once over the Docker layer and so on, and want to see what's going on. So, and I think 2 hours is not so much time if you're doing it really of the whole stack and all this stuff. So I think it is first time for the summary. And second, yeah, if you have any questions, feel free to ask. I don't know if it's allowed to activate your microphone. I don't know, but otherwise just ask or write it in the chat.
I will allow everybody to talk now. So I'm updating that
everybody
now.
at the same time.
Okay, so if you have a question, you are more than welcome to come off mute and ask. Or if you're feeling shy, you can always enter it in the Q&A section.
Yes. So until I am hearing the first question, I'm just summarizing. Be aware of this polyglot environment. Check for all technologies that are involved. Don't forget your tool stack. Check this one as well. So if you're using Jenkins, then check your Jenkins. Why not? And you can do it in different ways. So you can have different single tools, but I really will give you the advice that you have a tool that's scanning the whole tech layer so that you have a combined picture and the full impact graph. Shift left as much as possible. So even inside your IDE, so that you have all informations as soon as possible. And wow. By the way, if you want to know how to do it with the Vardin stack, just check out this repository. Or if you really want to try how to map web components to the Java side. So, any questions? Let's see. Nope, no questions so far.
Okay, just for folks' reference, I dropped in the chat the YouTube playlist where this will get updated to. So I'll clean it up after we're done, and then I'll post it on this playlist. So if you want to refer to it or share this with other people, this is where this will get populated. And if we don't have any questions, I will not take any more time from Sven and the attendees, and we can wrap up. So last chance,
otherwise,
folks.
Yeah. Otherwise, connect via Twitter, connect via LinkedIn. So if you have any question tomorrow, just feel free to ping me. So, okay.
Great. Well, thank you so much, Sven. It was a great presentation, and we hope to see you again.
Okay. Thank you very much, and bye-bye.
Bye.